Okay, so good evening, everyone. So for today, we're going to have a discussions about a measure of central tendency. So, measure of central tendency is a statistical measure that represent the typical or central value of a data set. So the three most common measures of central tendency are the mean, median, and mode, as what we discussed last time. So the mean is calculated by adding up all the values in a data set and dividing by the total number of values. And it is useful actually measure when the data set is normally distributed into does not contain any outliers. Now, the median is a middle value in the data set when the values are arranged in order. So it is a useful measure when the data set contains outliers or when distribution is not formal. And the mode is the value that occurs most frequently in a data set. It is useful measure when the data set contains categorical or discrete data. Again, each measure of central tendency has its strengths and weaknesses, and the appropriate measure to use depends on the type of data and the specific research question being investigated. And to give us more details about the topic, let us all welcome our presenter for this afternoon. Go ahead.
Good evening, everyone. We are Group B, and we are going to discuss about measure of central tendency. A measure of central tendency, it is a summary measure that attempts to describe a whole set of data with a single value that represent the middle or center of its distribution.
The mean is computed by adding all of the numbers in the data, together dividing by the number elements contained in dataset. Mean is the average of the dataset. For example, for example, 2 plus 5 plus 9 plus 3 plus 5 plus 4 plus 7. Then divided it to the number of elements in data. And all of the data and all the add all the data and divided it to the number of elements in dataset. Next. Median. The median of a dataset is dependent on whether the number of elements in dataset is odd or even. First, reorder the dataset from the smallest to largest. Mark off high and low values until you reach the middle. If there are two middles, add them and divide by 2. Median is the middle of our dataset. For example, we have a given dataset. You must first reorder it to lowest to highest, then find the middle number, and that will be our median. But if we have two middles, you must add them, then divide it to 2. Next. Mode. The mode for a dataset is the element that occurs the most often. This happens when two or more elements occur with equal frequency in dataset. Next. It happens when two or more elements occur with equal frequency in dataset. For example, first dataset, there are 2, 5 in dataset, so our mode is 5. Second dataset, in this set, we have 2, 5, and 2. So our mode is 2 and 5. Next.
Now I'm going to discuss how to solve mean median mode of a group data. So we have a given data group here. For age, we have 12 to 18, 19 to 25, 26 to 32, 33 to 39, 40 to 46, and 47 to 53. So we have a given frequency here. We have 12 to 18 ages of 5. For 19 to 20, we have 6. To 26 to 32, we have 5. 33 to 35, we have 8. 40 to 46, we have 5. And the last one is we have 1. So if we added all the frequency, we're going to get the number of elements 30. To get the mean, we have a formula here that f of x divided by n. So first, before we get the f of x, you must first solve the x so we can get the f of x. Para ma-solve to is we need to add the 12 and 18, then divided by 2. Then lumabas yung x. Ganon din sa 1925. Pag in-add natin siya, tapos i-divide mo siya sa 2, lalabas yung 22. So na yun, proceed lang. 26 plus 32 divided by 2, 29. Then we have to times the f to x. So 5 times 15, we have 75. Then 6 times 22, we have 132. Then 5 times 29, we have 145. Then we have 288, 215, then 50. So we need to add this all. Then we get the total of 905. So we have here the 905. You need to divide it to 30. So we got the mean of 30.1667. For median, we need to get the lower boundary first so we can get the median. Ang kailangan mo lang gawin is i-minus mo lang siya sa 0.5 sa lowest dito sa given data natin. Kunyari 12 minus 0.5 lang, so makukuha mo siya 11.5. Sa 19 naman minus 0.5, makukuha mo naman yung 18.5. Yun, tas so forth. So this is the pure formula for median. We have the lower boundary, the 25.5. First, so our for median, we have the 25.5. Then for our I, it is interval na makikita nyo sa age kung ilan siya. Kunyari, 12, 13, 14, 15, 16, 17, 18. Yung interval niya 7. So our I is 7. So para natin makuha yung yung median class, nandito yung formula niya. Yung n, i-divide mo lang siya sa 2. Meron tayong yung f, meron tayong 30, i-divide mo lang siya sa 2, so makuha natin yung 15. Tapos ayun na yung 15 lalabas dito na sa ating n over 2. So sa cumulative frequency, kasi less than less than ba tama? Ayun, we have 11. Kasi pumasok yung median natin sa 16. So we have 11. Sa naman, f sub n, meron tayong 5. So ayun, meron tayong 5 sa f sub n. So i-minus natin yung 15 sa 11. Makuha natin tong 4. Yung 25.5 plus 7, 4 over 5. Tapos dito, gagawin natin ng multiplication. 7 times 4 equals 28 over 5. Then add it to 25.5 plus 0.56. Makuha natin yung median na 31.1. For the mode naman, kukunin din natin yung lower boundary of mode. So ayun din yung lower boundary ng mode niya. Since sa mode natin, ang may pinakamataas na lumabas is 33 to 39, which is 8. Then, ipa-plus din natin siya sa interval natin na 7. So, f sub 1 minus f sub 0 divided by 2 f sub 1 minus f sub 0, then minus f sub 2. So, ang natin, ang f sub 1 natin is 8. Ang f sub 0 naman natin is 5. Then the f sub 2 is 5 din. So ito yung kakalabasan niya pag sinolve nyo. 32.5 plus 7 interval. Tapos 8 minus 5 divided by 2 times 8 minus 5 then minus 5 equals to 32.5 plus 7 then 3 over 6. Ganon din, multiplication din. 7 times 3 over, kaya lumabas yung 32.5 plus 21.6. Ayan over 6. So pag sinolve mo yan, lalabas yung 36 natin na mode. Measure of dispersion. A measure of dispersion are descriptive statistics that describe how similar a set of scores to each other. The more similar the scores are to each other, the lower the measure of dispersion will be. The less similar the score are to each other, the higher the measure of dispersion will be. So in general, the most spread out distribution is the larger the measure of dispersion will be.
Range. The range is defined as a difference between the largest and score in the set of data and the smallest score in the set of data. X sub I minus X sub Example next. Example, data set is 4, 8, 1, 6, 6, 2, 9, 3, 6, 9. The largest score X sub I is 9 and the smallest score X sub S is 1. Range equal to X sub I minus X sub S is 9 minus 1 equal 8.
For our variance, variance is the average squared deviation from the mean of set of data. It is used to find the standard deviation. You can see here the formula of the variance. Standard deviation. It shows the variation in data, and if the data is close together, the standard deviation will be small. If the data is spread out, the standard deviation will be large. So this is the formula for our standard deviation. So I have an example here. You have an ungrouped data set, 62, 63, 65, 64, 68, 68, 69, 72, and 66. So gumawa ako ng group data para mas madali siyang isolve. So ganun din, kukunin din natin yung min ng ating data set. Pag in-add mo lahat ng x, then divide it sa number of elements since 10 sila, makukuha mo yung 66.1. Then sa ayun yung number of natin ng elements is 10. So in order to get our x minus m, ayun nga, para makuha yung 66, yung x minus m, i-minus mo siya sa x minus m. Ayan. 62 minus 66.1, lalabas is negative 4.4. 63 minus 66.1 equals negative 3.1. 65 minus 66.1 equals negative 1.1. So ayun nga, i-times mo lang yung given data set natin sa min, then lalabas na yung x minus m niya. Tapos i-squared mo lang siya. 4.1 squared equals 16.81. So para makuha natin yung x minus m squared, i-add natin lahat ng x minus m squared. So pag in-add natin lahat yan, lalabas yung 86.9. Then i-divide mo siya sa number of elements natin, then lalabas na yung variance natin na 8.69. So gagamitin natin tong variance para makuha natin yung standard deviation. So kukunin lang natin yung square root ng variance para lumabas yung standard deviation. So yung result natin is 2.95. So that will be the standard deviation.
Measure of skews. Skews is a measure of a symmetry in the distribution of scores, which is a positive skew, normal skew that is also zero, and negative skew. Next, please. The measure of skews. The following formula can be used to determine the skew, which is this on the picture. Measure of skews. If S cube is greater than 0, then the distribution has a negative skew. If S cube 0, then the distribution has a positive skew. And if S cube equals to 0, then the distribution is symmetrical.
Kurtosis. Kurtosis is a measure whether the scores are spread out more or less than they would be in normal distribution. So we have here the presentation of the kurtosis graphs. When the distribution is normally distributed, its kurtosis equals 3, and it is said to be mesocortic. When the distribution is less spread out than normal, its kurtosis is greater than 3, and it is said to be leptocortic. When the distribution is more spread out than normal, its kurtosis is less than 3, and it is said to be platycortic. Platycortic. This is the formula for the measure of kurtosis is given by. That would be all. Thank you.
So a while ago, no, as I mentioned, no, that measure of central tendency are important in statistics and data analysis because they provide a summary of the typical central value of data set. And there are certain reasons no, why measure of central tendency are important. Number one, easy to understand, no? Because measure of central tendency are easy to understand and interpret because they give us a single value that represents the center of data, making it easier to describe and compare different data sets. Number two, useful for making predictions because measure of central tendency are often used to make predictions about future outcomes. Let's say, for example, if the average salary of an employee is known, it can be used to predict the expected salary of a new employee. Now, number three is the basis for further analysis. Again, measure of central tendency provide a basis for further statistical analysis. Let's say, for example, mean and standard deviation can be used to test hypotheses, conduct regression analysis, and calculate confidence intervals. Number four, it helps identify outliers. It is so important actually, no? Because measure of central tendency can help identify outliers, which are values that are significantly different from the other values in the data set. This can be important for detecting errors in data collections or identifying unusual cases that may require further investigation. Overall, measure of central tendency are important tools for summarizing and analyzing data and are used extensively in wide range of fields, including business, science, and IT and social science. Actually, kurtosis is a good one of the dispersion is important also, no? Because kurtosis is a statistical measure that describes the degree of thickness, no, or flatness of a probability distribution compared to a normal distribution. A distribution with high kurtosis has a sharper peak and thicker tails, no, while a distribution with low kurtosis is flatter and has thinner tails. Of course, as our presenter, we have three types of kurtosis, no? Meron tayo tinatawag na mesocortic, no? This distribution has the same kurtosis as a normal distribution, which is 0. It means that the tails of the distribution are similar in thickness to the normal distribution. We have also leptocortic, no? This distribution has kurtosis greater than 0, indicating a sharper peak and thicker tails than a normal distribution. It means that the distribution has more data points actually clustered around the mean, no, and fewer data points in the tails. And the last one is the platycortic. No? This distribution has kurtosis less than 0, indicating a flatter peak and thinner tails than a normal distribution. It means that the distribution has fewer data points around the mean and more data points in the tails. No? So kurtosis is the useful measure of understanding the shape of a distribution and can help identify potential issues such as outliers or non-normality. However, it should be used in conjunction with the statistical measure of fully understand characteristic of a data set. Okay. Now, a while ago, I've mentioned about the variance, and somebody already discussed about the variance, Variance is a statistical measure that describes how it's spread out a data set. So it measures the degree of variation of dispersion of the values in the data set from the mean. Di ba? Pag sinabi natin mean, average value. So to calculate variance, you take each data point in data set, subtract the mean from it, square the result, and then average the squared differences. So the formula for variance is equal to, of course, sum of the squared differences from the mean divided by the number of data points. A high variance indicates that the data points are spread out over a wider range of values, while a low variance indicates that the data points are more tightly clustered around the mean. So variance is useful in many statistical analysis, including hypothesis testing, regression analysis, and quality control. It can help identify outliers, determine the amount of error in the measurement, and assess the reliability of data. However, it should be used in conjunction with other statistical measures, such as mean and standard deviation, to provide a complete understanding of the characteristic of a data set. So a while ago, I've mentioned about the dispersion, Okay, so dispersion is a statistical measure that describes how spread out the value in a data set are. It is general, term that encompasses several specific measures of validity or spread, including variance, nasabi nga natin kanina, or what else? Standard deviation, range. And I'm looking with interquartile, range, mean, and absolute deviation. That's why I'm looking with somebody who would be able to demonstrate on how we'll be able to get, of course, the class size, I'll be able to determine the lower boundary, the upper boundary, and so on. Then dispersion measure help us understand how much variability or spread there is a data set, because a data set with low dispersion has values that are clustered around the mean, while a data set with high dispersion has values that are spread out over a wide range of values. So the choice of which dispersion measure to use depends on the characteristic of data sets and the research question being investigated. Let's say, for example, variance and standard deviation are commonly used when the data set is normally distributed and has no outliers, while the interquartile range is used when the data set is skewed or has outliers. So in summary, dispersion measures are important statistical tools that helps us understand the variability in spread of data set, and they are used extensively in a wide range of fields, including IT, business, science, and social science. So a while ago, I've mentioned about skewedness, Skewness is a measure of asymmetry of a probability distribution. So it describes the degree to which a data set deviates from a normal distribution in terms of symmetry. So a normal distribution has zero skewness, which means that the distribution is perfectly symmetrical around the mean. So positive skewness, di ba, may positive, may negative tayo. So positive skewness occurs when the tail of the distribution is longer on the right side than on the left side. And the mean is greater than the median. This means that there are more extreme values on the right side of the distribution than on the left side. On the other hand, no, negative skewness occurs when the tail of a distribution is longer on the left side than on the right side, and the mean is less than the median. And this means that there are more extreme values on the left side of the distribution than on the right side. Yeah, so skewness is important measure of the shape of probability distribution, and it can provide also, no, it can also provide insights, no, to into the underlying characteristic of a data set. It can also help identify potential issues with data collection or measurements such as outliers or non-normality. No, so statistical analysis it is important to consider skewness along with the measure of central tendency in dispersion to gain a complete data set. Now, I'm always saying about outliers. No, actually we discussed it already. No, about the outliers and or normality. Outliers and non-normality are two potential issues that can affect the distribution of a data set, and the skewness is a measure that can help identify these issues. Again, outliers are data points that are significantly different from other data points in a data set. No? And outliers can arise due to measurement errors, data entry errors, or simply due to the natural variation in the data. Outliers can have a significant impact on the mean and variance of the data set, and they can distort the shape of the distribution. Skewness can help identify outliers by indicating whether there is a significant departure from symmetry in the distribution. So non-normality, on the other hand, refers to a situation where the data is not normally distributed. So a normal distribution is a symmetrical distribution with a bell-shaped curve, and many statistical methods assume that the data is normally distributed, and non-normality can lead to bias or incorrect result. So skewness can help identify non-normality by indicating whether the distribution is skewed to the left or right, or whether there are multiple peaks or outliers in the distribution. So skewness is a useful measure that can help identify potential issues in outliers or non-normality in a data set. It should be used in conjunction with other measures of central tendency and dispersion to fully understand the characteristic of a data set. Now, so I just want to reiterate once again that this will be a content or a coverage of a descriptive statistics. Okay? So as what we discussed from the very beginning, actually a while ago, no, by our presenter up to present. Sorry, no, but we're going to have. Actually, we discussed about the descriptive statistics. Now, under the descriptive statistics. Wait. Okay. Because again, in this method, we're going to look with the research design, data collection methods, data analysis techniques, sampling quantitative research, of course, and the validity and reliability. No? So again, some common measure of descriptive statistics, no, already discussed, and I'm looking forward actually, as I mentioned, with the discussion or a discussion of percentile, quantile, no, in the position of particular value in the data set relative to the skewness and kurtosis described, no? Because again, percentiles and quartiles is a of course under the what we call this one, dispersion, no? Nabubulol ako. Measures of dispersion, no? So actually, percentiles and quartiles are measure of possession in the data set that are commonly used in a descriptive statistics. Now, so a percentile is a value below which a certain percentage of the data falls. Let's say, for example, the 75th percentile is the value below which 75% of the data falls. Percentiles are often used to identify outliers or extreme values in the data set or to compare the position of a particular value to other values in the data set. On the other hand, quartiles are a special case of percentiles that divide the data set into 4 equal parts. So the first quartile or Q1 is the 25th percentile, which separates the lowest 25% of the data from the rest of the data. And the second quartile or the Q2 is the median, no, which separate the data set into the 2 equal halves. No? And the third quartile or Q3 is the 75th percentile, which separate the highest 25% of the data from the rest of the data. Quartiles are often used to summarize the distribution of a data set and to identify potential outliers. The interquartile range or yung IQR na tinatawag natin, which is the difference between the third and first quartile, is commonly used measure of dispersion that is less sensitive to outliers than the range, no? Which is the difference between the maximum and minimum values in a data set. So percentiles and quartile are useful tools to summarizing and analyzing data sets and can provide insights into the distribution of data and position of the particular values relative to the other values in the data sets. Okay, so of course, a while ago, no, I've mentioned about range, no. Range, actually in statistics, range refers to the difference between the largest and the smallest values in a data set. So it is simple measure of dispersion that provides an indication of how spread out the data is. So to calculate the range, you just simply subtract the smallest value from the largest value. Let's say, for example, if you have the following data set, you have 2, 5, 7, 10, 15. The range would be 15 minus 2 is equal to 13 because the highest value from 2, 5, 7, 10, and 15 is 15, and the lower value is 2. So 15 minus 2, that is 13. So the range is quickly an easy way to get the sense of the spread of data, but it has some limitations. Now, it is sensitive to outliers, meaning that extreme value can have a large impact on the range. Now, additionally, it does not provide any information about the distribution of the data, such as whether it is symmetrically or skewed. Despite its limitation, the range can be a useful tool for getting a quick overview of a data set, particularly when combined with other measures of dispersion, such as the variance of standard deviation. Okay, so still downloading actually the file now. Even I just want to play it already, no, but still downloading. So maybe we could be able to discuss na lang this next meeting. So for the